Okay, our last conic we're going to cover are hyperbolas, and this gives you the standard form for the hyperbolas. I want you to notice the big differences are the subtraction that are in the middle, because it looks very similar to an ellipse, and instead of your A being in an ellipse, A was always underneath the whichever direction the ellipse went. In this case, A is always underneath the positive one, being the one in front of the subtraction. So if X is in front of the subtraction, you have a transverse, your transverse axis is horizontal, meaning that your hyperbola looks like this. If your Y is in front of the subtraction, your A is underneath, always under the first one, that means you have a vertical transverse axis, and your hyperbola looks like this. Okay, here's a picture of two of the hyperbola cases. If your transverse axis is horizontal, you're side to side, you do have what we call a center, HK. It's just the middle of the two vertices. Each of these are a parabola, and they do have a focus. So this point out here is a focus, a focus. This is what we're calling the center. These are still vertices. And the same if the transverse axis is vertical. Okay, now I'm going to draw on the other one. It has the same parts, but there's some parts you cannot see. It's like the directrix of a parabola. You don't see it, but it is there. So from these two vertices, we have this box that comes out. And over to the sides, B is kind of like our minor axis for ellipses. A takes us to a vertex. B takes us to an invisible vertex, co-vertex if you will. C will take us all the way to the foci. So when you're writing your equation in standard form, you need your H, you need your K, both come from your center. You need your A, your distance to the vertex from the center. You need your B, which takes you to your co-vertex, which is invisible again. But usually you can find your C, which gets you to your focus. You use the equation A squared plus B squared equals C squared in order to solve for anything you're missing. Okay, find the standard form of the equation of the hyperbola with the foci at 0, 0, and 8, 0, and vertices at 3, 0, and 5, 0. First thing you want to do is draw a picture. Figure out which way this is oriented. If I have a foci at 0, 0, and a foci at 8, 0. Okay, I'm going to label these with F so I know that they're foci later. Vertices at 3, 0, and 5, 0. So 1, 2, 3, 0, 5, 0. So only one thing can happen here. My hyperbolas have to be opening left and right, which means standard form, I'm going to be starting with x squared. I've got to know h, k, a, and b. So I look at my center, which is going to be right here. So what's that going to be? 4, 0. So there's my h and there's my k. My a is my distance from my center to my vertices. So this little spot right here is A. C takes us from the center to the foci, either way. B is the one that we're missing here. B goes, so now I know HKA has got to be 1. I don't know B, because remember it's that invisible box thing out here. I do know C. I know it is 1, 2, 3, 4 units away. So A squared plus B squared equals C squared. tells me 1 plus b squared equals 16. B squared equals 15. This is as far as you need to go, because in standard form, I start with x squared, x minus h, so x minus 4, quantity squared. Front one, positive 1, the one in front of the subtraction is always over a squared, so that'd be 1. Remember, hyperbolas have a subtraction in the middle. Y minus k, so y squared, over b squared, this is why we didn't have to take the square root of 15, equals 1. Okay, here's a picture of showing you the distances, a good picture of showing you the distances. This one takes you to A, this one takes you to B, and then they're not showing C, and that's okay because you know what it is. This asymptote is the other part of the hyperbola that you can't see, and it has a formula to go with it. If it's a horizontal hyperbola, if it's a left and right, this is your formula. If it's up and down, this is your formula. And it's the same thing. You need your HK, A, and B. Okay, sketch the hyperbola, whose equation is 4y squared minus 9x squared equals 36. We know all hyperbola equations have to equal 1. So we're going to divide everything by 36 and reduce. So now I've got y squared over 9 minus x squared over 4 equals 1. So I know this is my a squared because it came first. This is my b squared. It came after the subtraction. Since x and y are alone, they have no quantity squared. I know that my h is equal to 0, my k is equal to 0, which means my center is going to be at 0, 0. Since my y is coming first, I know this hyperbola has to open up and down. So now we can kind of sketch that out. I've got my center at 0, 0. It has to go up and down 3, since A equals 3, to get to the two vertices. And there's really, for a sketch of a graph, you don't need to put B in, you don't even need to put the foci in unless it's asking for it. This would be the sketch of this hyperbola. Okay, one that's not in standard form. We're going to do the same thing we do with ellipses. We need to group our x's, group our y's, put our constant on the right. So 9x squared minus 4y squared plus 8y equals 40. There is nothing to complete the square with for x's. It's just going to stay 9x squared. For the y's, though, I need to take out that 4, like we did in ellipses. That's going to leave me with y squared minus 2y that I have to complete the square with. 9x squared stays out here, minus 4, double parentheses, y minus half of this number, squared, always subtract. 1 squared is 1, close, equals 40. Distribute. 9x squared minus 4 times y minus 1 squared plus 4, remember you're distributing a negative 4, equals 40. Subtract the 4. 9x squared minus 4 times y minus 1 squared equals 36. Everything needs to equal 1, so divide by 36. And now we have x squared over 4 minus y minus 1 squared over 9 equals 1. Center as at HK, so it's going to be 0 and positive 1. This is still my a squared, so my a is equal to 2. My b is equal to 3. Remember, we're just sketching. We don't need all the details. We do need the asymptotes, which was just a and b. So my center at 0, 1 Which way does this go? Since I started with x squared, this is a left and right, so I need to go left and right 2 for my vertices. This question did ask for the equation of the asymptote, so I'm going to follow the formula. Y equals k plus or minus b over a times x minus h. So y equals, our k was 1, plus or minus b over a, parentheses, x minus h would just be x. And if you were checking your work in the back of the book, they might have it in a slightly different form, 3/2 x plus or minus 3/2 x plus 1. One more example. Find the standard form of the equations of the hyperbola having these vertices, and this time it gives me the asymptotes. Okay, let's start by drawing a picture of seeing what we're dealing with. I need to be at 3, 2, and 9, 2. 3, 2 here. 9, 2 here. So if those are my vertices, my hyperbola has to be going this way. From this information, I could also figure out the center between these two would be right here. Let's see, this one was at 3, this one was at 9, so the middle is going to be 6. So I know my HK, 6, 2. And then, let's see, we got to write it in standard form, so we have to know our HK, A, and B. We know that A has got to be 3. It's this distance. Okay, from our asymptotes, we always know this fraction right here with x was, if it was a left and right, this is b over a. So in both cases, I know that my b equals 2. And now I can put it in a standard form. It's left and right. It's going to start with x minus 6, quantity squared, over, I want it to always be over a squared, minus y minus k, quantity squared, I always want this to be over b squared, equals 1. We didn't have to dissect all of that right there to get the information, just what we needed.